Okay, everybody okay? Everybody can see me now? Hopefully. Okay? Alright. Alright, so I kind of shut down a couple of the windows here. Let's hope that I can get through another example without it crashing like crazy. I'm monitoring it right now, but I'm gonna have to probably make some memory tweaks. See if it's acting up. So, not sure. Not sure why that happens to be the case. It's really weird. Okay. I haven't had this issue before, to be perfectly honest, but okay. I guess it is what it is for right now, anyway. Okay. Sorry for the delay, everybody. I'm gonna have to chop this video up into 3 parts at this pace. Alright. Okay. Well, let's move on here. Let's try the next one here. Maybe I'll try the paint tool one more time. If it doesn't like that for some reason, then I'll have to try something different. Alright. Yeah, I don't know what's going on. So I'm like, crashed twice. I'm gonna have to live with it. I could always find an alternative to the paint tool just in case anyway. So I always got an idea. Otherwise, I'll just have to manually just fudge stuff around so the memory doesn't get hogged away. All right, so let's do the next problem here. All right. All right, so the next problem here, let's go ahead and do number 3. So number 3 here is going to be, again, finding the area underneath the curve from 0 to 8 of 8x minus x squared dx. If we take the derivative of the, integral of this, we get 8x squared over 2 minus x to the third over 3. All right, there we go. And let's go ahead and clean this up here. We get 4x squared minus x to the third over 3. And then all we're going to do here, again, evaluate it from 0 to 8. That's all we're going to do. We're going to plug in 8 first, then we're going to plug in 0, and then we're just going to see what we get. That's it. I promise you that's all we're going to be doing. So we're going to do 4 times 8 squared minus 8 to the third over 3. So that's the first part there. And then we're going to subtract that by... Oh, no. Okay, there we go. And then we have 4 times 0 squared minus 0 to the third over 3. Now, of course, 0 times anything is 0, so you're just going to subtract by 0. So let's see what we get here on the right-hand side. We'll go ahead and use a calculator for that. You can use your own calculator. It's really not too bad. So we get 4 times 8 squared. That's 256 minus was 8 to the third over 3. So it's 512 over 3. And then we just oh, what did I do? Okay. Picked the wrong button. I get to the canvas. I would like a picture of a Triceratops, please. Exactly what I want. Whoa. No. Okay. So we go with 256 minus 512 over 3. We'll fractionize that. So here we get 256 over 3 is our final answer. Okay. So that's all it's going to be for that one. Hey, Fobs, how you doing, my friend? Wow, hey, buddy, how you been? Andy, what you been up to, my man? I hope you've been well. I haven't been ages since I last talked with you, my friend. I hope things have been pretty chill. Hey, Nick, no problem. Bobs, I'm just teaching my my calculus class, my dude. Sorry, I just missed that message. I was just trying to do the calculations there. I apologize about that. But yeah, I hope you're doing really well. I gotta come by your stream again sometime. I apologize about that. Andy. That's on me. But legit, man. I hope you're doing wonderful. Nick, I'm glad that you're here. You came at the right time. This got I don't know if he left or not. I don't know if Andy, you still here? Bob's, you still here? I don't know if Bob's is still here, but Bob's is a really good dude. He's a wonderful singer. Was part of a boy band in the UK. So wonderful guy. Absolutely outstanding gentleman. He's been part of the entertainment scene for a long time. So it's definitely one of those guys that you'd like to know. He's got a good personality, wonderful singing voice, just an all-around great dude. All right. Any questions? I guess is the question. Any questions about? Any questions at all? Yeah, Andy, Bob's boy band was very large over in Europe, so definitely. Then he decided to head out and venture on his own. Makes his singer-songwriter. Wonderful guy. Okay. Ready to try another one? Okay. Let's try another one. This time. This time I'll give you the pick. Give you a pick of the litter here. Oh. And today has been kind of all over the place. So it's a memory thing that's been going on. Alright, hopefully this thing will just not happen. Okay. So, which one would you like me to do? Would you like me to do 4, 5, 6, 7, 8? 4, 5, 6, 7, or 8? 9 is kind of the same-ish here, but actually we'll do one of those three. So 4, 5, 6, 7, or 8. You guys pick them. I'll do that one out of those guys. So 4 through 8, pick one. You get your choice, everybody. You get your choice. Elizabeth says 6. What about you, Lee Wen? Nick? Emma? The 6, okay. Alright. We'll wait for Emma and Lee Wen to chime in. Alright, we're doing 6, okay. So it looks like 6 is the way to be. Let's do number 6. So, number 6, we're going to be doing the integral from -8 to -1 of 4 minus the cube root of x. All right, and the x. All right, so let's do it. What is the integral here? Well, before we do the integral here, I am going to rewrite the integral. All right, so we're going to have 4 minus x to the 1/3 power. So remember that that is another equivalent way to write the cube root of x. All right. So in this instance, what we're going to do is, again, once we put it in x to the 1/3 power, we're going to use the power rule here. Gonna figure it out. So the integral here is 4x. And then don't forget here, remember we're adding 1 to the 1/3 power if we're using the power rule here correctly. So here we get x to the 4/3. Okay, so remember that's x to the 1/3 plus 1. And then you'll have 1/3 plus 1 down here. So this will be the x to the 4/3 over 4/3. We'll clean this up a little bit. We'll do 4x minus 3/4. Again, you divide by a fraction, you flip it. X to the 4/3 power. Okay. And we're going to evaluate it from -8 to -1. All right. So let's plug in -8. So we get 4 times -8. All right. Minus 3/4 times -8 to the 4/3 power. So that'll be 1 section. Let's blow this up here for a moment. And we'll subtract that by plugging in -1. So we'll have 4 times -1 minus 3/4 -1 to the 4/3 power. Okay. Now, again, I fully expect you to use your calculator for these two parts here, so be sure to get your calculator spots right. In fact, for this one here, I am going to showcase the calculator. Hopefully it doesn't totally crash everything, but we're going to give it a shot anyway. So let me check that out actually. Alright, it likes it. Alright, fine. That's fine then. It's so weird, my computer's acting super weird today. Alright. Alright. So let me show you how you would put this in the calculator. So we have here, of course, 4 times -8. That's pretty easy. That's -32. But if you want to like do it all out, let's say you want to do it all out, which is fine. You could do 4 times -8 minus, and in parentheses here, 3/4. And then you put -8 in parentheses, and then hit the caret key, and then in parentheses here, put 4/3. So you'll have to be a little careful about putting the parentheses in the correct places in your calculator. But if you do that here properly, then actually this whole thing will be -44. And then you could do the same thing here for the other one. Do 4 times and then parentheses -1 minus and parentheses 3/4. Again, -1. And then raise that to the parentheses 4/3. And so here we get -4.75. We'll convert this into a fraction in just a second, but let's go ahead and subtract here. Get -44 minus -4.75. And so we get negative 39.25. Now remember what we said here. Negative values are okay for area, okay? So this is fine here for this particular problem. If you want to convert negative 39.25 into a fraction, you can do it this way. You can hit the math key. You can go to number 1, which says fraction. And it will tell you exactly what it is in fractional format. It is minus 157 over 4. And there we go. Got it. So if we go ahead and take a look here at the guy. Let's check it out. And we can see that that's correct. Oh, wait, did we get it? Oh, I was looking at the wrong one. Did we not get that right? It should be x to the 4 thirds. Should be 3/4. Oh, did I do that backwards? Well, maybe I did. Let me check. Maybe I accidentally did 8 first instead of negative 1. I forgot about that. Check. Oh, I did do it backwards. I'm so sorry, everybody. That's my fault. Bad habits. I keep thinking. I looked at 8. I did the same thing probably you guys did. You're supposed to do negative 1 first because negative 1 is the larger number. Okay, so technically this should be backwards. So this should be there. Okay, I'm going to do it in a different color. This should be there, and then this should be over here. So what you should actually have is, totally my fault. So we have minus 4.75 minus a negative 44 is what we actually have. So ignore this part here. This part doesn't count. Blah, 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 blah. All right, so now let's do that on the calculator and let's figure that out. All right, so we get 39.25, and that should be positive 157 over 4. Okay. So that's what we should get here for this. And now let's check. Let's just put it as a positive. Yeah, my apologies. I just did it backwards. And let's just take that off. And should get it now. All right, we got it. All right, good. Okay, good. All right. It's not that hard. Again, start with the bigger number minus a smaller number, and then that's pretty much it. All right. Let's take a good look here at some of the other problems here. That one's pretty easy. So I'll let you guys pick between 10 and 14. Okay, so the next example here is between, actually, I'll do number 10, and then from 11 to 14, I'll have you guys pick. So you guys pick first, 11, 14. I'll do number 10, and then we'll move forward. That'll be the next two examples here. So let me know which one of the numbers you want me to do between number 11 and number 14 that you see there on the screen. Make it a bit bigger. $14, okay. Okay. Let's go ahead and do number 10 and number 14. Okay. Now, just to let you know, if you wanted to do numbers 11, 12, or 13, all you need to do is FOIL out exactly what these expressions are. So, for example, x minus 3 times x minus 5 is like x squared minus 8x plus 15. and you would do the integral of that. So be sure to FOIL out these three problems here. You would FOIL out. Number 14 is a little bit different than FOILing out, so we'll FOILing out, distributing, whatever you want to call it. That's a little bit different. Now number 10 here. Let's go ahead and do that here in this instance. I think I know what's going on, but anyway, I think I'll have to do that off screen though. We're doing the integral here from 1 to 8 of 8 over x dx. Okay, so let's recall here one important thing. This 8 here is a constant. We can bring that out here on the outside. That's 1 to 8 of 1 over x dx. Anybody remember? What is the integral of 1 over x? What is the integral of 1 over x? What is the integral of 1 over x again? ln of x, okay. Be a little careful here. Natural log is correct, okay, but natural log of what? Be sure you put natural log of, let's not forget here, this is important. It's natural log of the absolute value of x, okay? So you have to be sure it's the natural log of the absolute value of x here, okay? So we have 8 times the natural log of the absolute value of x. Why is that important? Because the absolute value of x, again, makes that positive, and you'll be able to do that problem here even with negative values. So here we get from 1 to 8. So let's plug it in, see what we get. So we get 8 natural log of 8 minus 8 times the natural log of 1. Clean that up a bit. You get 8 natural log 8 minus 8 natural log of 1. All right. Let's take a look at that particular part there specifically. Just a little side note for this one here is that natural log of 1, you do that out, is equal to 0. Okay, so technically you have minus 8 times 0. Essentially, natural log of 8 is some gobbledygook number. Okay, I don't know what it is, but it doesn't really matter. The important part here was actually the natural log of 1, which effectively made it 0 at the end of the day. So this basically cancels out as a result, and that just leaves you with 8 natural log of 8 at the end of the day. Okay. So if we put in the answer here, specifically for this one, and why I want to show it off is, if you put 8 natural log of 8, okay, that would be sufficient for the final answer for that. But I just wanted to point that out, be like, oh, where did that come from? Like, okay, well, you don't have to like put the very long decimal that natural log of 8 is. It's some random decimal, but notice that it will accept the answer here of natural log of 8. That's perfectly acceptable. Okay. All right. Let's move forward here to number 14. You notice how fast these problems are. These problems are rather quick, so which maybe you like a little bit more than the previous problems. All right. So here we got we have the integral from 1 to 4 of 1 plus 1 over u plus u to the minus u plus 1 over u squared. I'll change that actually in a second. Okay, I kind of figured. All right, we do the integral here from 1 to 4. Oh, actually, I take that back. Let's do the integral first of 1 plus 1 over u plus u to the minus u to the 2. Again, actually, let's rewrite it. Let's do that. Let's take it slow. So we get 1 plus 1 over u, and then we're going to keep this, we're going to change this to u to the minus 2. Okay, notice I did not change 1 over u, because just like the last problem, we know that the integral of 1 over u is, the integral of 1 over u is the natural log. It's the special one. I'm going to keep that as 1 over u, but 1 over u squared is, well, that's its own animal. So the integral of 1 is just u. The integral of 1 over u is the natural log of the absolute value of u. And the integral of u to the minus 2 is going to be specifically u to the minus 1, since we're adding 1, and dividing it by negative 1. Okay. So that's what we have here so far. Let's make it a little bit easier to digest, and then we'll go ahead and plug in the numbers. And then we should get, hopefully, a nice answer to go with. We get u plus the natural log of the absolute value of u. And then we have a minus, because we have a minus sign down here with the minus 1. And we have u to the minus 1. And we could easily deal with that with the calculator and whatnot, so no worries about that. Okay. Now, let's go ahead and plug in the numbers here appropriately. We're starting from 1 going to 4. So we'll start at 4, subtract the 1, and then we'll get our final answer. So first one, we'll plug in 4. So 4 minus the natural log of the absolute value of 4, minus 4 to the minus 1. Okay. Minus, plug in that 1, plus natural log of 1, absolute value of 1, minus 1 to the minus 1. Okay. So far, so good. So now, let's see what we got here. This is 4 minus natural log of 4. 4 to the minus 1 is going to be 1 over 4, so 1/4. Let's see what we have on the right side here. We have 1. Natural log of 1 is 0. And 1 to the minus 1 is still 1, so that's fine. All right. So this 1 and minus 1, they'll cancel out. That just leaves us with 0 on this left-hand side. All right, what do we get here? We get 4 minus 1/4. Let's do that on the calculator there. 4 minus 1/4. Put that as math fraction. So that's going to be 15 over 4. So right now on the left-hand side, I have 15 over 4 minus natural log of 4. And again, subtracting by 0 nets us absolutely nothing. So that's going to be our final answer. 15 over 4 minus natural log of 4. And that's it. So let's plug that in. And let's get down here. Oh, what did we miss? Did 15 4? Let's see if I'm missing something. U to the minus 2, that's right. Wonder if I mixed something up here. Let's check it out. That's still 1. That will net us 0. That's fine. Oh, you know what I did? Oh, I see what I did. Okay. Yeah, it should be 4 plus, right? Why is it 4 minus? Yeah, you're right, Liwen. You're correct, Liwen. I totally missed that. I put minus here instead of plus, so there should be a plus here, right? Yeah. I did plus over here for some reason. I didn't do plus over here. Yeah, you're correct. You're correct, Liwen. That's correct. Okay, so that technically this should be plus instead of minus. Okay. So I just was missing a sign there. Okay. Yeah, I accidentally skipped a sign there. All right, there you go. All right, so it was just the sign change. All the numbers were correct. All right, good. All right, thank you for correcting me there. Thank you very much. All right, any questions about that? Questions? Nope. Okay. All right. All right, so we're going to do one more problem here, of course. All right. And so let's go ahead and figure this out. All right. And let's see what we're working with here. So I'm going to go ahead and do, let's do, I don't know, got pretty much every choice in the block if I wanted to. I guess we'll do number 17. That'll be fine. So let's do 17 here. All right, so 17 says a division of Ditton Industries manufactures a deluxe toaster oven. The daily marginal profit function associated with the production and sales of the deluxe toaster ovens is known to be that thing. Okay, where X denotes the number of units manufactured and sold daily, and P prime of X is measured in dollars per unit. Management has determined that the daily fixed cost incurred in the production is $800. Right? Find the total profit realizable from the manufacture and sale of 200 units of the toaster ovens per day. They give us a little hint here. P of 200 minus P of 0 is equal to 0 to 200 P prime of the X, where P of 0 is equal to negative $800. Okay, so they give us basically if there's a plus C part of it here, we got to factor in the $800 from the fixed cost that we have from the initial outset of the problem. All right, so you're probably saying, what exactly does that mean? I said, all right, well, let's look at it from the numerical standpoint, and let's do it. Okay. All right, so I'm going to write down the function here. So, okay. So there's our guy here. Now notice it does tell us from 0 to 200. That's what we're going to be doing here. We'll go from 0 to 200. We'll factor in this minus 800 at the end here, by the way. So we'll figure out what that's going to be. But let's at least start with this. Now, if we do this out here properly, this isn't too hard. I mean, we're just using the power rule here repetitively. So we're doing the integral of this. So doing this out here, we're going to net negative 0.0006 x to the third over 3 plus 0.06 x squared over 2 plus 23x. All right. If we clean this up a little bit, we will be able to get, we'll be able to make the numbers here a little bit nicer. So here we get 0.0002, okay, x to the third, plus 0.03 x squared, plus 23x. Now again, we're going to evaluate this from 0 to 200, okay? We're going to do the definite integral here from 0 to 200. So let's plug in 200. So 0, 0, 0 to 200 to the third plus 0.03 200 squared plus 23 times 200. All right, so that's all the first part here. And effectively what I'm going to show off, I'm going to just take a shortcut here. You're just going to subtract by 0, because if you plug 0 into each of the x values, that's still just going to make it 0. So I'm just going to, it doesn't happen for every problem here, but for this one it does. Just to save on writing, I'm just going to forego doing that. So now we want to go ahead and plug this into the calculator and see what we get. We'll need to take one extra step after that. So let's take our calculator out again. Oh, I shouldn't forget the negative out here, by the way. Should be negative. Yeah, it should be negative. So let's plug it in. So negative 0.0002 times 200 to the third power plus 0.03 times 200 squared plus 23 times 200. All right, so here we get 4,200. Okay, so we do get a nice value of 4,200 after everything is said and done. Now we do have one more thing that we do need to showcase here, and that is they do give us a fixed cost here. Our fixed cost is that it costs them $800 to produce these toasters every day, this daily fixed cost. So that's going to cut into your profit because you have a daily fixed cost. So we're going to take that 4,200 and subtract it by the daily fixed cost of $800. And then so your profit here will be $3,400. Okay. So notice $3,400 here is correct. Good. Now it does ask you here for letter B. It asks, what is the additional daily profit realizable if the production and sale of the toaster ovens are increased from 200 to 220? So what is the additional daily profit realizable if the production and sale of toaster ovens is increased from 200 to 220? So essentially we're going to go from 200 and we're just bumping it up to 220 at the end of the day. So let's see what the additional daily profit that is realizable from that is going to be. We're going to take, again, you take the same derivative, the same integral here that we just found. And now we're just integrating it from 200 to 220. Okay. Because we just want the additional daily profit realizable. Okay. Not the total profit. Okay. Realizable. The additional. So Doing the same thing here. And again, you're just going to do this twice. So again, you're going to do, you're going to enter in same guy here. Okay. You're just going to go from 200 to 220 here. So start at 220 for the third. Plus 0.03. X squared, so that's 20 squared. Plus 23 times 220. And then we're going to subtract that from the 200. Now, in our case, we can take a little shortcut here as well. Why is that? Because we already know how much the profit is after 200. We said the profit after 200 was found to be $4,200. So that's what happens when we entered in the first part there. So we're going to take that whole value, this whole value that you see here on the screen. We're just going to go ahead and subtract that from 4,200. Subtract 4,200 from that. So let's enter this into the calculator, see what we get. Okay, and we'll find out what happens.